Hello everybody, welcome back to today's session. It's a continuity from the previous session where we learned about self-attention. We coded our own implementation of the scaled dot product attention, right? Now in today's video, we are going to implement the masking. We are going to see how many ways self-attention has been applied in the transformer, and then we want to understand that for each of the cases how masking is applied, and then finally going to code them all. This is what is the standard encoder decoder architecture of the transformer. We have covered them in the first video of the transformer. We are going to the self-attention where all it has been applied. So the first thing is that the red colored, what you can see here, this border is the multi-head attention. Forget about multi-head attention for the time being. We are going to have a special video only on this to cover how multi-head attention differs from the dot product, scale dot product attention or self-attention. Right now you consider this is the self-attention. So place number 1 where it is applied. Now this application is very similar to what we had learned in the dawn of self-attention, right? Here it is called the intra-attention because it is applied within the encoder itself that you can understand. So also there is another term which you will see in tutorials. For example, TensorFlow has a tutorial on transformer. There it is mentioned as global self-attention. So whether it is intra or global self-attention, the characteristics is that here we are applying on the same words. So the Q, K, V, their shapes are same. Effectively it will produce a square matrix as the attention output. And then here the mask is only padding mask. We already learned about what is padding mask and all, but now let's go a little deep inside the masking. We have learned this in our positional encoding video. We have already learned that although the padded sequence carries the 0, this 0 is lost when we move towards the embedding and the projection, linear projection, they becomes a learned representation. But to retain that these are not important for us, we produce a Boolean array which will carry the true and false. The false positions will indicate that attention need not focus on these areas, right? So that was the mask portion. Now attention was actually in the form of attention score was in the form of a matrix. We learned in the last video. I requested you to take a special note on that at the end of the day your attention score, attention weights, as well as the attention output, all of them are metrics. So this one dimensional mask, true false Boolean mask, need to be converted to a matrix. So you see how this has been applied here. As you can see that if you just quickly check, for example, if you are talking about the first word with respect to, let's say, third word, first word, the one position with respect to the third word should be true, right? That is what it is showing. But first word with respect to, let's say, fourth word, first word with respect to fourth word should be false. Okay, and similarly if we are talking about the fourth word with respect to first word, fourth word with respect to first word should be false. So likewise, so if they are the rows, I know the 4th and 5th row should be completely false, right? Because they are all 0 here. Similarly, if we are talking about this as a, the column, then I know this 4th and 5th column should be if. So that's how it has been converted as a matrix. We will run through this and see that what technique we are applying to code this masking for the padding mask. Now this is about the mask which is true and false, but then how this mask is actually applied to this code, let's understand that part. You see this mask which is true and false value gets converted into a numerical value, which is wherever you have true, that is converted as 0. Why, we'll just come to know. Ideally it could have been 1. So true normally says 1. In between we will convert them as a not operation, so the true become false and false becomes true, and then those are finally converted as a numeric number as 0. And wherever you have false, we put a minus negative infinite number it is basically a very large number, negative number. That's how we'll reorganize this mask into a value inverted matrix. Remember that. Now this will be added with the actual score. The score will be looking like this. The original score will be looking like there are this green region. You can see there are a lot of floating point numbers. That's how the score will come, right? And this grade number are also having something which we want to ignore. So now they are added. So now the resultant score will be, you can understand, this green region will remain as is because they are 0. So this addition will have no impact on them. However, whenever this large negative value is applied on them, this will effectively become very close to 0. That's how the mask is actually applied on this score, right? We go back. So that is one place where self-attention is applied along with masking. Let's go to the second one. This is the second portion where decoder is getting input in terms of training data, where the entire data is given. Although you are supposed to predict the next word is also supplied, right, in a teacher's forcing method. You remember, if you have forgotten, go back to our video, autoregressive decoder or the vanishing gradient video, where we have also explained how the teacher forcing works. So teacher forcing was especially on that video, but subsequently more elaborate explanation was there in the autoregressive decoder. What is the nature of this self-attention, you understand? We call this as a causal attention. Causal attention because standing at any sequence, let's say we are at the 5th sequence or 2nd sequence, we are only given access to the previous one. So given the word, what is the next word is what I am trying to predict. That is why it is causal. But when you apply the mask here, the mask has to only give the previous information, not the future information, because future is what the model is supposed to predict. So you are not going to give access to that. The padding is called here look ahead masking. Wherever it is next word, those are masked. Wherever it is the previous word, that is given access, right? That's all. Let's understand how it works. As the first word has appeared, you see all the next words are false. The second word appeared, now given access to the first word, but all futures are masked. Third appeared, so you have the previous two given access, the next three are given mask. Okay, like that, as you reach to the last one, all of the tokens are giving access, right? That's how it works. If you follow the shape of this matrix, this is a lower triangular matrix, right? This is nothing but a lower triangular matrix. So if you have a code which somehow can generate a lower triangular matrix, we are done. That's nothing but a causal mask. Okay. Now, causal mask is not alone here. You also have to remember, we also have padding mask. So wherever the combination, a AND operation, wherever causal mask and the padding mask both have true, that is what going to be the net masking. So let's say for simplicity we have considered all the sequence have this similar padding mask. In that case, what will happen is that after third sequence, basically the causal mask has a larger effect, right? But at this point, which is fourth sequence, we can see it is matching. But when it is, let's say, fifth sequence and sixth sequence, you see at the fifth sequence, although the causal mask is saying that I am giving access to all the 5 words, padding mask is saying no, I have some more, so I am only giving 4. Here it is given access to all of them, but padding mask then overrides and then it says no, you have only given access to 4. So the combined access will be something of this sort, right? After that, this will be converted and then negative values will be applied, added to the score, and the score will be, the position of the mask will be made 0 for the attention score. Apply same as we explained before. Now that's the second place where self-attention is applied. Now the third place, this is what is important. This is what actually we have learned in all the previous encoder-decoder setup. One coming from the decoder, which is the query, right? And the key and values are coming from the encoder. Why it was done? Because of different shape. The encoder, which is in German language, decoder, which is in English language, the length may not be same. To address that issue, we said that the encoder and decoder architecture was required. Go back to our video. We have a encoder and decoder architecture, particularly sequence to sequence learning. It was there, the various types of RNN architecture, and then we moved on to the encoder decoder to address this problem, right, which is unequal length of when we are doing a machine translation. Fine, so we are back to that place. So this is what we call it as a cross attention or inter-attention. In the dawn of self-attention, we have said that this was actually, that time authors had termed this as inter-attention, right? So same thing applies here in the transformer as well. So it is inter-attention or cross-attention where shape of Q is not equal to K and V, which is coming from the encoder, right? And the mask here is the Q mask and the K mask. Both this mask has to be applied here, right? Let's see how it is. So the technique which is applied for this unequal Q and KV is like this, that you have earlier, we know that this is how the value mask was coming, which is from the encoder, right? So if we have to create the matrix form of it where Q and KV are not similar, the first thing we do, take this mask as is here, put it here 0 to 1 as a column matrix, or think of it this way, that we are actually converting all this true, 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 false, false, each of this mask information as a row. Each one of them has become a row, right? Now we have the query mask coming from the decoder, and that we are converting as a row matrix, or in other words, each of the mask is treated as a column, right? At the column dimension we want a expansion, and that we put it here. Now we do a AND operation between them, and then we can just see that for 0 to 3 basically they will match this similar pattern. For example, if you talk of 3, then 3 the third row applied on the fourth column will be true. Third row applied on the seventh column will be false. So it follows the same pattern. Up to this it is getting repeated. But when you come to 4 and 5, because of the 0, the entire 2 row will become false. So that's how is the technique here. You take one column matrix, you take one row matrix which is from the query, then do a AND operation between them, then you broadcast them. You see this is getting broadcasted. So you broadcast them and do a AND operation, and then you get what you are looking for, the complete matrix. That's what we will do as the code. Okay, so that's all about the 3 applications of self-attention within a transformer setup and their masking techniques, right? Let's do the coding now. Here we are. We said in the last video, we will come back here. What we are doing is that we are trying to compute the attention mask from the compute attention mask method. Now this compute attention mask method, I have tried different approaches, but finally what I have written here is the version which is already there in Keras Multihead attention. Where is that? Why it is not showing? Yeah, this is the Keras Multihead attention. As is, I have taken the compute attention method, so not so important. Let me come back to our code. I have just copied those portion with a little bit of modification. Let's now explain you what is going through. So as we know from our positional encoding video, how the masks were formed, how Keras layer provides you this hidden attribute which is Keras mask. So given the query, value and the key, we are simply going inside this and then collecting the mask information from query, from the value, from the key, right? After collecting them, this is the query, key and key mask. After collecting them, we are doing this auto mask calculation. What it means is that query mask is first converted to a boolean, just to ensure this is a, like he says, defensive casting. So although they are passed as true and false as a boolean array, you are making sure that when TensorFlow graph computation happens, nothing goes wrong. So you are just making it doubly sure it is boolean, right? Then after that you are calculating this, which you are actually broadcasting this query mask to be broadcasted along the column direction, right? This is what we are doing. And the value mask has to be broadcasted along the column direction, where it is showing the BT broadcasted along the column direction. P1 is, which means 1 is the column, so that is what is the broadcasted. What is B? B is the batch, T is the target, T is the target sequence, and S is the source sequence, which is the encoder portion, right? And that's how you, after the broadcasting, you calculate the auto mask at this portion, which is basically now they are combining it. A key is also same as value, so either it is key or the value, end of the day same logic applies. You see, if say it says that you do a AND operation here, right? And wherever you don't have any information, because we took only one row and one column, so there are places where we don't have any value. Those values you can put it as whatever is equivalent to the mask information. Whatever is the mask, you put it there. Otherwise, wherever you have a values, you come check both of them, and only when they are same, only when they are both are true, then you put a true. Otherwise, if one is true, another is false, you will put a false. That's what is the AND condition, right? So we did that for value and the key, and essentially what we have in hand is the auto mask, and that's what is the padding mask, right? Now we are going to the causal mask. Okay, causal mask, as we said, is first you have to compute the causal mask, and there are many examples, but there is only one single line which is calculating the lower triangular matrix. If you remember, all we have to do is somehow create a lower triangular matrix. So the signature for creating such thing is band part. It is the linear algebra, one such method is there, which is band part, and the signature is that you give the original matrix, this portion is the original matrix, then you say which portion you want to keep. This is the lower matrix, the lower half, and this is the upper half. So we are saying that the lower half you don't touch it, I mean just keep it as is, and then upper half you put it as 0, which means the upper half you will put it as false. Whatever is there, I mean you will just invert it, right? That's what it is saying. Now what you are supplying here as a source matrix in the signature is the tf.1s, one batch number, one such thing, and then it is a matrix which is where row is equivalent to the query, and the value is the value sequence length. So we are creating a matrix of 1, then converting that as a boolean, which is true and false. So everywhere it will be true and false. How many trues as row? Basically that would be equivalent to the length of the query, and how many columns? That will be the length of the B, okay, which is the encoder length of the sequence, encoder length of the sequence, and all of them are true. Now when it passed through the band part, you retain the true in the lower half, -1, don't do anything, and the upper half you inverse it by making a 0, which will automatically become false, right? So end of the day you get a lower triangular matrix where all the lower part is true, upper part is made as false. After computing this causal mask, which is named here as mask, what you are doing is that you are combining these two, which is you have the auto mask before, which was the padding mask. So padding mask and the currently computed mask, which is the causal mask. Between these two, you again do a AND operation. Wherever you have both places you have true, it will convert it as a true. Wherever you have opposite, true or false, it will be false. So that's what it has been done in the causal mask portion. So it's a combined mask now what we have here. Apart from that, so kept a provision of providing additional masking information, which is called the attention mask. So when this attention mask is not there, if attention mask is none, anyway you take whatever has been computed. But if the attention mask, which is an additional masking information, if you are providing, then you again do a combination of that mask, which is attention mask, and this, which is AND operation. It's not required. So it is just I have written as they have provided, I have written it. And then this portion is a repeat of this finally calculated attention mask, which is nothing but the auto mask combination of causal and the padding, is repeated. Why it is repeated we will understand only when we go to the multi-head portion. Basically multi-head will be splitting, or rather parallelly doing self-attention multiple times. So the mask information will only come once. That's how we are repeating those mask information here. We will get more clarity when you go to the multi-head attention portion. Okay, now coming to the testing part. So basically we are initializing this. We explained up to this one. What we skipped this portion in the previous video. So what you see is that the score before mask is like this. Then we said that how the original column mask was there, which is we said that you see there are only two third bracket here, third bracket, okay, only two, which means it is broadcasted. This will be of this dimension, one single row. Now this is where we have the row mask. This is what you see, there are three brackets. So this entire thing then can be thought of as a column, which will be now repeated, right? So end of the day you have the combined mask coming into picture, where as you can see this is the third three brackets here. So these are repeating, you see this true, 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 false, and these are repeating as per the combination of combination of the row and column. So that's how this mask is formed. Now you just also get to see that wherever you have true, those are becoming 0, inverted, and wherever you have false, that is becoming 1, because this is where you will give a large negative number. Let me come back to the code once again and show you how the mask score has been applied. We have gone there. If you just go to the PPT, this is the place where you have the mask need to be converted. Wherever you have true, you will have the 0. Wherever you have false, you will have a large negative number. This will be added, and the result of the addition will make all the masked position as close to 0 values. So the same thing we are going to do now. This place, here we are. So get mask score, right? How is it done? You are passing the raw score. Imagine that green patched raw score thing, and you are passing the mask as a Boolean array, true and false. So the true and false first is inverted, logical not of mask Boolean. So the true become false, false become true. Wherever you have true, that becomes 1 now by this casting. True becomes 1, right? And then in those ones, we are going to push a very large negative number. This is the large negative number, and this large negative number, which is multiplied with 1, and large negative number multiplied with 0, where 0 remains 0. So all this 1 position is now added, essentially subtracted from the original score. So the score positions become very negligible. So that becomes 0, right? Coming back to this position, this is how the mask score has been applied here. So first mask score, you can just see on account of this effect, as you can see what is going on. The mask score is retaining this, these are valid position. Now you are going to the mask position. You see this is a large negative number, -1 to the power e to the power 9. So all of them are having the same effect here. You come back to this portion, see all of these last positions are there, and when you come back to the rows, it is also giving you the same thing. This is the score. Now what it will go to the, this is the score which will go to the softmax, and something will happen. This column will become 0, because basically what they're saying is that if these are all my score, how do I weight them? Obviously wherever you have negligible value, so those will become 0, and wherever you have some good value, that will have a higher weight as per the softmax for this entire row. Or if you take this as the column on this row, it will weight each value with respect to their number, and therefore the last few number where we have put very large number, those will become 0. Quite understandable as far as, but this down below, this couple of rows will actually not become 0, you know, that will not become 0. Let me show you. See, this is the default implementation of the Keras Multihead attention. So you can see that when we are getting the score from here, this is the score. You see there also the columns are 0, but when you come to the last few rows, right, the entire row is having a false value, which means for that row all the elements are actually having equal number, even though they are very largely negative. When it goes to the softmax, they will be of equal weight, right? So that's what is getting reflected here. You see, they are the last few rows where all the values are false are actually having equal number. Understood? Now this is what I couldn't digest. Okay, why? I mean, you are applying mask, the columns are becoming 0, and I have to pass the score information. The attention is in the matrix format. If you are trying to neglect the rows, the columns, why keep the rows? So I have this additional implementation here, which will forcefully make even the rows which are of equal weight as 0, so that a multiplication with the v also becomes 0, not equal number. I mean, the argument here is that if you are weighting a v with equal number, then model will understand that they are equal, they are not equal importance, so they will ignore it in terms of who is higher and which is lower. But I am trying to say that even you can make it better, that you make it 0. So I have a switch here. I wanted to understand what will be the impact of keeping it this way vis-a-vis the other way. I have this switch here, is that row masked to 0. Some mistake here, 0. That's how it continues. I made the mistake. The entire code will continue like that. So row mask to 0, which means row mask set to 0. If I set it to 0, it will take this additional step here. If I have this switch on, then whatever score has been produced, on that score I will further apply this mask float, okay, so that you know, these are 1 and 0, nothing but 1 and 0. So therefore the final attention weight, if I apply 1 and 0, wherever you have 0, that will become 0. Wherever you have 1, it will retain the score. So if I just do that, then my output becomes little more understandable, which means my columns where mask has to be applied is 0, my rows where mask has to be applied is also 0. So this is the additional tweaking which we have done here. Okay, now we spoke about the causal mask, which is one more switch. If we use the causal mask is equal to true, in that case your combination, you know, the combined mask will take the causal mask and the padding mask combination. So that we have already explained in the code, and we can see the net impact is similar to that one, right? Yeah, so that's it in this video, which is explaining about the different way masking has been implemented in the self-attention, and also in 3 places in the encoder decoder transformer setup, in 3 places how differently the self-attention has been applied. Now in the next video we are going to learn how several of the self-attention is applied as a multi-head attention, and why actually we do it. We'll give some example and do it. Also implement our own multi-head attention on top of the self-attention, so that we are learning block by block. If you go to the TensorFlow's tutorial, this is where you will find a huge disconnect. One was the positional encoding I have explained you. I couldn't understand why they are creating 2 different set and why they are not interleaved. So apart from that, when you go to the multi-head attention, they will straight jump into their multi-head attention library. So you will not understand how the masking has been implemented. Also you will not understand what exactly is happening under the hood, right? So that's how we have implemented multi-head attention. Also not throwing up the self-attention. We'll just build on top of that, and then finally you will get to see, may not be in this in the next video, but subsequent video will compare the codes between our own implementation and the default implementation of where you are using the TensorFlow multi-head attention. Okay, so next video will be on multi-head attention. See you then. Stay tuned. Okay, we are coming back very soon.